Hello all, welcome to Embedded Linux Learning Point, a learning platform for anyone who wants to learn Embedded Linux and to grow in this field. In the previous video we have learned how to view file content without opening any editor. By the end of this video, we will learn how to look at the running process or programs, how to monitor process in real time, and finally, how to stop running processes. So the first thing is, let's start looking at the processes. When a program runs on the system, it is referred to as a process. To examine these processes, we must understand how to use the ps command. It can produce a lot of information about the running process on your system. Okay, let me enter the command ps and see what it gives. By default, the ps command shows only the processes that belong to the current user and that are running on the current terminal. In this case, we only had our bash running and of course the ps command itself. The basic output shows the process ID, the PID of the process or the program, the TTY that they are running, the terminal that they are running from, and the CPU time the process has used. If we need to see everything that's running on our system, then we need to use the ps command with the -e and f parameters combined. So ps -e and f, you can see a lot of information was given. Here the means the option E stands for the show all process, maybe everything, and F is to display a full format listing which expands the output to show a few useful columns of the information. The information that it provides is UID, the user responsible for launching the process, PID, the process ID, and the PPID is the PID of the parent process, and C is the processor utilization over the lifetime of the process. The S time is the system time when the process started, TTY as before the terminal device from which the process has launched, time, the cumulative CPU time required to run the process, CMD, the name of the program that was started. You can see that the sbin init, the splash, this is the command that started, and it was started by the root. The PID of this program is the 1 and the PPID, the parent, is 0. As we know that the init process ID is 0, and TTY, it did not start from any terminal, so that's why we have the question mark here. And the S time is started on November 12, and the time it took is 000 on the 10th, so it's running for 10 seconds. And for even more information, we can use the parameter -l, which produces a long format output, something like this. Well, we can notice that there are some extra columns that appear when we use the -l parameter, and these are the F system flag assigned to the process by the kernel. You can see here the F. The S stands for the state of the process. Here, in that, if it is O, that means it's running on processor. S is sleeping or is runnable or waiting to run. Z is a zombie process, terminated but parent not available. The T means it's a process stopped. You can see there are some S, I, and there are some process. All are sleeping here, and this is the elf ps command which is currently running. And the PRI is the priority of the process. Higher numbers means the lower priority. So here you can see the PRI, it's 80 and things like that. Okay, here you can see the priority numbers. Ni is the nice value used for determining the priority. This one. ADDR, the memory address of the process. In this case, the ADDR is for a lot of processes. It is not given. Not sure why. And SSAT is approximate amount of swap space required if the process was swapped out. Here you can see the numbers for the SZ. And WCHAN is the address of the kernel function where the process is sleeping. The one useful parameter to display the process in a hierarchical listing showing parent process is to use the -forest parameter with the PS as shown below. Okay, so let's see, if you use the PS -ef with the forest, we would see something like this showing the parent PIDs. It's something like it shows as a tree. Let's do that. PS -ef -forest. It's -forest. As you can see that this is the parent and the bash is again started with the forest. So this is the use of the -forest. So you can also see there are a lot of processes that are started by this genome shell. Its genome shell is the parent here, and these are the children processes that have started. So for more information on PS command, you can check out the man page. The next thing that we will see is the real-time monitoring of the processes. Though we can use the PS command to peek into the running process, it has one drawback. The PS command can only display information for a specific point in time. If you want to see the processes running in real time, we can use the top command. The top command displays processes information similar to the PS command, but it does so in a real-time mode. So let's use the top command. Okay, here you can see it gives a lot of information, plus the information is refreshed at a certain interval. So the first section of the output shows general system information. The first line shows the current time, how long the system has been up, the number of users logged in, and the average load on the system. You can see it's the time and is up 3 days. So and here it is 1854. Here it means how long the system is up. There's one user. The average load is 2.43, 2.16, and 0.64. I think this is the CPU load. The load average appears as 3 numbers. It's like 1 minute, 5 minutes, and 15 minutes load averages. So here it is like what is the load for 1 minute and in 5 minutes, and it is the 15-minute load. So that's how you need to understand about this information. The second line shows general process information called tasks in top. How many processes are running, sleeping, stopped, zombie. So here you can see the tasks. There are 245 total tasks, and out of which 2 are running and 240, of course it varies, 244 are sleeping, 1 is stopped, and 0 zombie processes are running. The next line shows the CPU information. The top display breaks down the CPU utilization into several categories depending on the owner of the process versus user versus system process and the state of the process. It's running, idle, or waiting. So here it shows the CPU percentage. Following that, there are two lines that detail the status of system memory. The first line shows the status of physical memory in the system, how much total memory is there, how much is currently being used, and how much is free. The second memory line shows the status of swap memory area in the system with the same information. So this is about the swap memory, and this is the actual memory that's been consumed. And finally, the next section shows a detailed list of the current running process with some information columns that should look similar from the ps command, as we see. So here you can see the PID, the user, PR, NI, VIRT. It's the new thing here. It's the total amount of virtual memory used by the process. RES is the amount of physical memory the process is using. SHR is the shared memory, and S, as we know, it's the state of the process. CPU percentage is CPU percentage the process is taking, and the percentage mem is the share of the valuable physical memory the process is using. Time plus is the total CPU time the process has used since the starting, and the command is the command line name of the process. As you can see, I have started the OBS, this is where I'm recording, and the gnushell and things like that. So you can see by default when we stop, it sorts the process based on the percentage CPU value. You can change the sort order by using one of the several interactive commands. So if I press the F, it allows you to select the field to sort the output, and D allows you to change the polling interval, and Q for quitting the top display. So I'll press an F here, and here you can see the sort is based on the CPU percentage. And let's say if I want to sort based on the CPU memory, I navigate to percentage mem. In the percentage mem, using the down arrow command, down arrow key, and then if I press yes, here you can see it's changed to percentage mem. Okay, and then press an escape, and you can see that the sort is using the percentage mem. Okay, and let's say now again press the F. Again, if I want to go back to percentage, I go to CPU and then press yes, and the field sort field got changed to CPU percentage here. And again I press escape, and you see it's sorted with the CPU percentage. Well, now you can see that it's the interval is a little bit delayed. So if you press D, you can change delay from 3 to let's say if I do for 0.5 seconds, and let's see, you can see every 0.5 the information is loaded, so it refreshes with every 0.5 seconds. So with the D option, you can change the delay with which we see the data gets refreshed. So I'll go back to 3 as before. So that's about the top command, and to quit we use a Q, and once you quit you will get your terminal back. Okay, so now that we know how to peek into the processes, or now let's learn how do we stop a process or a running process. So in Linux, processes communicate with each other using signals. A process signal is predefined message that process recognize and may choose to ignore or act on. The developers program how a process handles signals. Most well-written applications have the ability to receive and act on the standard Unix process signals. So the standard process signals are: signal number is 1, name is hub, and the full name is hang up. So signal 2 means it is int, it's an interrupt. 3 is quit, stop running. 9 is kill, unconditionally terminate. 11 is segue, segment violation. And 15 is the terminate if possible. 17 is stop unconditionally but don't terminate. 18 is TSTP, stop or pause but continue to run in background. 19 CONT, resume execution after stop or TSTP. Okay, these are the signals that we have. So a few different commands are available in Linux that for us to send process signals to running processes. So this video discusses only the two commands, the kill and the pkill. The kill command allows us to send signals to process based on their PIDs. By default, the kill command sends the term signal to all the PIDs listed on the command line. We can use only process PIDs instead of its command name. So with the kill command, we can use only the PIDs. To send a process signal, we must either be the owner of the process or be logged in as the root user. So let's ps-ef. Okay, now we see there are a lot of processes that are running. So now let's try to kill a process by the name called sleep. Okay, here you can see it's the root user. The owner is the root user. And let me paste and see if I'm able to kill this process or not. You can see that the operation is not permitted because I am not the owner of this process. So let me run this with okay, now that we have one process that is owned by the user, the current user, and it is open board, let me kill this with this PID. Okay, and you can see that it got killed, and I don't see the open board in the PS list. Okay, so also we can send the other signals with the number or name using the -s parameter to the kill. So here again I'll start this open board application. -ef. You can see this is the open board PID and kill -s, and the signal which I would like to send is the stop. STOP. So for this PID, and you can see currently the you can see open board and the signal you can see this is terminated, the T. So that is how we use the kill command. Okay, now we have command called pkill. The pkill command is a powerful way to stop process by using their names rather than PIDs. The pkill command allows you to use wildcard characters as well. So let me just use the pkill command to kill the open board application. So pkill, and we can see that we will be able to kill with the name of the process here. Okay, and again now if you see the open board application or the process is not running. So that is how we use the pkill command. So for more information about the commands discussed, you can refer the links in the description which I leave. So with this, we've learned how to monitor running programs or processes in the Linux. So leave comments for any feedback or discussion. Also like the video and share with anyone who's interested to learn more about Linux. Thanks for watching.